Okay, so it's day 80 of 100 Days of ML, and I'm going to be continuing with Paper a Week. Yesterday, I presented my paper to the ML conference World is 4. It was a pretty interesting event. It was actually really fun to attend, although I have a final today, so it was very stressful and last minute, but overall, it was a great event, and the organizers were really friendly. Um, so I did end up freezing on the presentation for a few seconds, which was kind of annoying because I thought, like I just burned through this presentation without any problems. But yeah, I mean, it is what it is. Anyways, what I'll be doing today is reading section 10 of Statistical Modeling, The Two Cultures by Leo Bremen. And I'll just mute myself when I'm reading it, and then at the end, after taking notes on my iPad, I'll go through a summary of the section. I want to keep this stream fairly short because I have my final today at 10:30, so I gotta start studying for it in the next 30-ish minutes. So, all right, without further ado, I'm gonna go ahead and mute the mic and then start reading. All right, let's do it. So this section was actually really interesting. Um, it first talked about the dimensionality curse quoted by Richard Bellman. And Richard Bellman's phrase just says that, higher the dimensions, the worse it is for whatever you're trying to do. However, in recent published work has shown that dimensionality can actually be a blessing. And that's been true with deep learning and SVM and all of these algorithms. And so this is because of the fact that while reducing dimensionality, you actually end up reducing the amount of information available for your model to train. So instead of reducing dimensionality, we can increase it by adding functions of the predictor variables. Well, the more amount of information you have, usually the more complex your model becomes. However, you want to retain as much information as possible. That way, whatever your model is doing, either prediction or classification, could be the most accurate. So now the problem is, how do you extract all of these little pieces of information together? And two popular examples are shape recognition forest and support vector machines. And support vector machines are incredibly popular. So then I started talking about the MNIST dataset. So basically the NIST competition for reading handwritten numericals. And I guess this is where SVM started to shine, because he talks about using support vector machines for this example. And so he goes into support vector machines, talks about how SVMs work by finding the most optimal hyperplane for dividing up categories. And then he also talks about dimensionality reduction that's performed during SVM. So if you do have a data set that's really high in dimensions, you can just increase the dimensions by adding additional predictor variables. So instead of being a linear function now, linear optimal hyperplane, it basically, the kernel reduces the dimensions from whatever dimensions on. If it's like fourth dimension or third dimension, which is pretty small, it reduces it down to linear and then finds the best optimal hyperplane. So this method was shown to be incredibly useful for datasets like MNIST, since it performed incredibly well. But there is also a catch due to the fact that if the hyperplane becomes too complex, the generalization error becomes large. And a theorem was proposed for this, which was able to predict the generalization error. So the final conclusion was the fact that SVMs can also be used to provide accurate predictions, not just in this area, but also other fields like regression and whatnot. And so this really changed the perspective on dimensionality. Instead of being told to focus on less dimensions and focus on a smaller model, they started to implement models that are able to extract information from incredibly complex data sets, reduce it, and try to find the information that way. So I think next up is information from Blackbox, which is a step up from SVM. So we could go into most likely neural nets. And so I'll finish that tomorrow. I'm going to go ahead and call it a day today and start reviewing for my final. Okay, thanks for watching. I'll be back tomorrow.